Hi there. I'm Cheryl Biswas. You may know me as Encrypted Online. I am honored to present at AppSec Village. Welcome to my talk today, Signed, Sealed, Delivered, Abusing Trust in Software Supply Chain Attacks. I hope you enjoy. A little bit about me. I'm a threat intel specialist with a major bank here in Canada. Shout out to my awesome team. I'm also a founding member of the Diana Initiative, where we support diversity and inclusion in our field. Much love to the terrific staff, volunteers, and supporters who helped make another amazing event happen this year. I sincerely hope we can all meet together next year. And now for the obligatory disclaimer. The views expressed here today are mine alone, and not those of my employer. Okay, let's get started. In this talk, I want to explain what software supply chain attacks are and the growing threat they pose. We'll look at how code dependency is a factor, compounded by mistakes and misconfigurations. Then, we'll look at a brief history of some major attacks and the state-sponsored actors involved to talk about who's been watching and what they leverage. Finally, we'll wrap up with what we could do better and some suggestions. We don't fully appreciate just how interconnected we are and how that translates into software code dependencies. It took an event like the SolarWinds Orion attack to rattle the bars on that cage and wake us up to what's been going on for some time. The reality is that software supply chain attacks are not something new. They've been around for many years, and we've been watching that check engine light, but not really addressing the issues. My hope is that the knowledge I share here today gives you some new insight and awareness so that you can go back and better secure your projects. What a year! Even before we got out of the gate, the tone was set. SolarWinds was truly unprecedented. It's the kind of event that we talk about for decades. We build off of it and we learn from it. However, as you're going to see, there have been a lot of software supply chain shenanigans just over 2021. These types of attacks are an abuse of trust. They're compromise right at the source. The insertion of malicious code into legitimate software and then distributed en masse to trusting customers. This can create access points into the networks of those customers, up to the tens of thousands, as was demonstrated by SolarWinds Orion. And as we've learned, nobody is untouchable. Everyone is a potential target. Software supply chain attacks take time, resources, and skill to plan. This is the purview of state-sponsored threat actors, notably Russian or Chinese-backed groups. But both cybercriminal and state-sponsored groups target the technology industry because these companies are relied on by many organizations and individuals, and that can have wide-ranging impact. Attacks on tech companies can enable third-party compromise of enterprise customers via updates through software supply chains. For example, China has actively targeted tech companies in Taiwan with these types of attacks because they see them as major competition. Now, another important disclaimer. I am not a coder or a developer, and I'm not going to pretend to be one. I am presenting this talk from my experience as a threat intel researcher, and what I do plays a key role because we watch the geopolitics play out, and we reach back for historical context on patterns of behavior, because history repeats, and actions have consequences. Ian Pratt, the global head of security for personal systems at HP, had this to say: whether they are a direct target or a stepping stone to gain access to bigger targets, as we have seen with the upstream supply chain attack against SolarWinds, organizations of all sizes need to be cognizant of this risk. There's nothing like getting some historical context. So let's start with this. In 2009, Operation Aurora was a wake-up call when Chinese state-sponsored group APT-17 targeted Google, Adobe, and other tech companies for their source code management systems to alter the source code. And this is at the heart of a software supply chain attack. If you control the source code, well, imagine what you could do. This event led Google to implement zero trust, to track lateral movement, and to put in place better infrastructure. Interestingly enough, Google was not part of the mass fallout during SolarWinds Orion. And then in 2017, there was NotPetya, an elite Russian hacking team known as Sandworm, part of the GRU military intelligence service, compromised and took over software updates of a mandatory accounting package known as MEDOC. Now, this software was used throughout the Ukraine at tax time, and they didn't have the plethora of choices that we enjoy. It was pretty much that or bust. Russia has used Ukraine as a cyber petri dish for years to test weaponized cyber weapons in what has been a rather hostile relationship. Russia has control issues. So Sandworm used MEDOC to distribute a destructive malware known as NotPetya, which was supposed to be a punitive measure against Ukraine for daring to leave the mothership. But instead, that spread to infect major companies like Maersk as unintended consequences, and the costs amounted to more than $10 billion globally. In January of 2019, a sophisticated supply chain attack was discovered targeting the ASUS Live Update utility. Now, this is a pre-installed utility on most ASUS computers to automatically update certain components like the BIOS, UEFI, drivers, and applications. It's very convenient, something that end users would implicitly trust. And there are a lot of ASUS end users. In fact, according to Gartner, in 2017, ASUS was the world's 5th largest PC vendor. That would make it an extremely attractive target for APTs, advanced persistent threat groups, who might want to take advantage of that user base. In this case, that APT was Chinese threat group APT-17, also known as Barium, who happened to have been behind a number of software supply chain attacks. Nick Weaver, a security researcher at UC Berkeley International Computer Science Institute, shares this. You're trusting every vendor whose code is on your machine, and you're trusting every vendor's vendor. We're grappling with the growing sense of complexity in tech. It's not just what corporations deploy in their own environments, but how they are incorporating third-party tech. According to Windows Snyder, the product assumes all the security risk of all the components that it incorporates. So let's have a talk about our code dependency. Sorry. The fact is that applications increasingly depend on external software to work. Proprietary code, open source components, third-party APIs. Modern applications are just too big for one developer to do on their own, and software reuse has become the norm. Popular open source projects are used as dependencies, and these are attractive targets for an attacker to add malicious code to and then claim the users of those dependencies. We need to appreciate the increasing complexity of library use in applications, how the functions of one library rely on a number of other libraries in order to be implemented. This creates complex dependency trees that developers won't remove or update because of the possible downstream consequences. So let's take a look at some numbers. The average app has 118 open source libraries. The average library is 2.6 years old. The average Java app has 50 open source vulnerabilities. 99% of organizations have one or more high-risk Java licenses. And what are the false positivity rates using legacy SCA tools? Java has 23%, .NET 13%, and Node 69%. Per GitHub security researcher Maya Kazarowski, 85 to 97% of enterprise software code bases come from open source components, with the average project having up to 203 dependencies. And given how sophisticated those attacks can get, any projects that don't incorporate even basic protections like code signing put themselves at real risk. Because we're using other people's technology. It's a trust issue. Let's take a look at the 4 elements of a software supply chain. There's what you write, custom code that's developed in-house. There's what you build with, software development tools. There's what you buy, off-the-shelf software as a service apps. And there's what you use, third-party libraries. So we need to understand areas of risk around open source libraries and frameworks, which can come from active or inactive libraries or library classes, the age of the library, licensing, and of course vulnerabilities. But that's hard to do when you don't have visibility into the libraries and classes being used by the software, or when you're only relying on static scans from legacy security code analysis tools that go out of date as soon as that library changes or updates. This is from the 2021 Contrast Labs Open Source Security Report. There's a lot here to take in, but the key points are these. 1. If you're using open source code, you need to be paying more attention than you have been. What we're doing and what we've been doing to identify and remediate risks, it's not comprehensive enough. We're missing stuff. And the legacy security tools in use aren't securing us. We've got to level up. This is a timeline. No, it's a timeline of software package repositories that have been in supply chain attacks. It's really easy to just get code from various projects online and then incorporate that into other software. Here's the risk. Some of those open source projects are widely used, but not well maintained, or they've even been abandoned. Code reuse is a deliberate strategy. It's seen as a key differentiator for efficiency, innovation, speed, and application development, but at the cost of being vulnerable to compromised, off-the-shelf components. Now, some repurposed code comes from internal repos, but a lot of it comes from open source libraries, third parties. For an attacker, compromising a software supply chain can be through manipulation of the application source code, manipulating the update or distribution methods, or by replacing compiled releases with a modified version. Targets can range from either a very specific and limited group to a very wide number. Stuff happens. And that brings us here. The continuous integration, continuous development pipeline, which is a best practice for DevOps to deliver code change frequently and reliably. CI is a coding philosophy. It's a set of practices to drive development teams to implement small changes and then check in code to version control repositories frequently. It's a consistent, automated way to build, package, and then test applications. It's good, except you're using other people's technology, and mistakes will be made. In November of 2020, the FBI issued a flash alert warning that threat actors had been actively targeting vulnerable SonarQube instances since April of that year to access source code repos and exfiltrate proprietary code from U.S. government agencies and private organizations. The FBI found multiple potential computer intrusions that corresponded with leaks associated with the SonarQube configuration vulnerabilities that had been under exploit since April. In August of that year, unknown threat actors leaked internal data from 2 organizations through a public lifecycle repository tool. They scanned online for exposure via a default port 9000, a publicly accessible IP address, and default admin creds. Several of those sources had those as hard-coded credentials, which opened the door to accessing other resources and expanding the breach. Per Sakar Sarakai, who wrote in the McAfee blog from July 31st of 2020 regarding the SonarQube source code leak, because mistakes will be made. So let's talk about several major software supply chain attacks from the past, and about lessons that maybe went unlearned. If that looks busy, it is. The Identity Theft Resource Center, or the ITRC, stated that 137 organizations reported they were impacted by supply chain attacks at 27 different third-party vendors. That's an increase of 42% from the last quarter of 2020. Attackers will manipulate software dependencies and development tools to compromise data or systems before those reach the recipient. And as we've seen, they go after source code. In the case of SolarWinds, Microsoft said that attackers gained access to some of the source code for Exchange, Azure, and Intune. Having the source code gives adversaries the advantage because then they can go look for undiscovered vulnerabilities and be the first to exploit them. The attackers also go after certificates. Stolen code signing certificates let them evade detection and deliver malware payloads as though those come from a legitimate source. And certificate abuse is an ongoing component in all kinds of attacks. And let's talk about attacks. There's vendor compromise. That's the most sophisticated. There's exploiting third-party applications. So finding and exploiting vulnerabilities, especially 0 days. These bugs can enable an attacker to manipulate the software to do things that it was never intended for, including credential theft or accessing information. There's exploiting open source libraries. Now, these can also have vulnerabilities to exploit, but unlike software packages, it's harder to update and maintain open source code. And because that source code is openly available, attackers then can easily study it and practice on it. For example, the Apache Struts 2 framework. That had 13 critical zero-day disclosures just over 5 years. There's dependency confusion. We're going to talk about this a little later on. And then there's hostile takeover. An example is from 2018, known as Event Stream, and involving Node.js. When the original owner was approached by another community member who was willing to take over the management of his project, well, they handed it over in good faith. They transferred all that control. In a few weeks, malicious code was being downloaded via automated build tools and then deployed in numerous software applications. This code was designed to steal credentials from Copay Bitcoin wallets. It used encryption to hide its functionality, and the stolen credential data was sent to a remote server. Fortunately, some mistakes caught the attention of managers of the Node.js repo, and they thought that there was a bug in the package, and they looked further. So this is a good lesson about the abuse of trust. The assumption that the software supply chain is trustworthy and that anyone can create or contribute with no formal vetting process. This is a good depiction of how an attack uses dependency trees. I'll just let you take a look at it and not get into the weeds. This is from something known as the Backstabber's Knife Collection, and the link is there. SolarWinds, December 14th, 2020. A lot of us remember where we were that day, what we were doing, and what we wound up doing. SolarWinds Orion is trusted network management and monitoring software used by the government, Fortune 500s, Microsoft, FireEye, and nobody knew anything was wrong. It's been described as the most significant attack of our time. What's distinctive about it is the degree of stealth and the total ability of the attackers to conceal their actions. They had wicked good AppSec, and the length of time it took for discovery. This was an operation that took time and precision to do the reconnaissance, sophistication to tailor it, and patience. The attackers targeted and compromised the software build environment and code signing infrastructure for Orion. They modified the source code to add a backdoor, and they signed it. They leveraged the existing software release management system, and then they used stolen certificates to laterally move through chains of trust. Dependency confusion, as promised. This is a very interesting attack. Security researcher Alex Burson shone a bright light on a scary possibility. He took a hypothesis about a supply chain substitution attack where a software installer script is tricked into pulling a malicious code file from a public repository instead of getting that intended file with the same name from a trusted internal repository. Then he went on to target Apple, Microsoft, Tesla, and 32 other companies so that he could execute unauthorized code inside of their networks to prove this worked. It did. And within 48 hours of publication of this, a lot of other parties thought it was a good idea too. So, without permission, they targeted some more companies in March of this year, and those included Microsoft, Amazon, Slack, Lyft, Zillow, and more. Here's the issue. Existing dependency scanners typically don't detect if a dependency executes malicious code, since these tools are limited to identifying dependencies with known vulnerabilities. Now, this prompted a study by researchers at Red Hunt Labs. And what did they find? 93 repositories out of the top 1,000 GitHub organizations are using a package that does not exist on a public package index. This can be claimed by an attacker to cause a supply chain attack. 169 repositories were found to be installing dependencies from a host that is not reachable over the internet. 126 repositories were installing packages owned by a GitHub or GitLab user that doesn't exist. And of the top 1,000 organizations scanned, 212 had at least one dependency confusion-related misconfiguration in their codebase. Now this matters because, according to the researchers, much of our open source ecosystem depends on these particular companies, and we know that these repositories have a lot of users. So, if any of the projects get affected, there is a high probability that potentially millions of users could be at risk. Xcode Spy. we know that attackers are targeting developers. They're targeting those shared sites, the repositories where code is uploaded for use by others. In March of this year, a new malware variant was observed targeting iOS developers in a supply chain attack to install a backdoor on developers' computers. This is a malicious project, and it's taking advantage and abusing this free application development environment. It's abusing a common behavior by developers to share their projects online with other users. And the threat actors behind this abuse that norm, and they used a legitimate development environment created by Apple to fool their victims into adding an online project to their app that would, in effect, compromise their systems in a supply chain attack. It's an abuse of trust. CodeCov. This is an online platform used for hosting code testing reports and statistics. It provides developers with tools to help them quantify how much source code gets executed during testing. Now, they serve over 29,000 customers globally, and many of those are enterprise level. They include companies like GoDaddy, Atlassian, Royal Bank of Canada, Procter & Gamble. But the impact went beyond them to thousands of public development projects, things like Ansible, Kubernetes, PyTest. And victims included Twilio, Rapid7, and the e-commerce platform Mercari. On April 1st of this year, CodeCov reported that a supply chain attack had actually occurred back in late January. What happened was this. Attackers leveraged an error in the process that creates CodeCov's Docker image. So this allowed for them to extract credentials, which protect the modification of the bash uploader script. That's a tool that's used by customers to send their code coverage reports to the platform. There's a lot of stuff included in those code coverage reports. Now, the script was modified to deliver details from the customer environments to a server that was outside of CodeCov. And then attackers could export credentials, tokens, or keys that passed through CodeCov's continuous integration environment. And then they could use those to access services, data stores, or even application code. What were you doing on the July long weekend? Yeah, a whole lot of us were doing this. Kaseya is an IT solutions developer for managed services providers and enterprise-level organizations. Over 40,000 reportedly use at least one Kaseya product. They offer something known as VSA, which is a unified remote monitoring and management tool for networks and endpoints. Yeah, that sounds familiar, doesn't it? Which happens to have a high level of trust on customer devices. So much so that attached clients will do whatever they are told. And therefore, that's likely one of the reasons that Kaseya was targeted. So on July 2nd, REvil ransomware operators delivered a fake VSA update, sending a ransomware payload from compromised VSA servers to VSA agents that were running on managed Windows devices. Let's talk trust issues. Initial compromise through a trusted channel that further exploited the trust in that VSA agent code. Initial access came from exploited zero-day vulnerabilities in Kaseya's VSA software, and it leveraged those against a number of MSPs. The attack was triggered via an authentication bypass vulnerability in the Kaseya VSA web interface. And then this allowed for the attackers to circumvent authentication controls. They got an authenticated session, they used that to upload their malicious payload, and then they executed commands via SQL injection, achieving code execution in the process. The malicious update was dubbed the Kaseya VSA agent hotfix. So trust issues? Well, that hotfix was already good to go, thanks to anti-malware software exclusions that got set up for Kaseya at the time of installation. And then the attackers attempted to disable MS Defender using a signed certificate shown here. The current tally is about 50 Kaseya direct customers and anywhere from 800 to 1,500 small to medium-sized businesses along that chain who got infected. Some of these weren't even Kaseya's customers. The thing is, from an impact standpoint, these are smaller companies. They don't have the financial or personnel resources that enterprises do to deal with a major ransomware attack. So let's talk now about who's maximizing these opportunities. Of all the state-sponsored adversaries, Chinese cyber espionage groups have been and will continue to be, I think, the biggest threat to tech because they conduct economic espionage and intellectual property theft. Technology companies, as we know, are rich targets just on their own, but these groups leverage them to infect supply chains and go after those customers. They are definitely the leaders of the pack in terms of the number of attacks and capabilities. Now, this chart is from the report Broken Trust that was issued earlier this year by the Atlantic Council. And in it, they reported 36 other cases of intruders successfully targeting software updates from about 138 recorded supply chain attacks and vulnerability disclosures. Of these 36, 15 had similar access to build or update the infrastructure, and half of those 15 could be attributed to nation states. These are some of the most well-known supply chain attacks involving Chinese state-sponsored threat actors. While Russian adversaries are formidable, oh yeah, SolarWinds Orion, you really don't want Chinese APTs in your network. They play the long game better than anybody else. They're masters of stealth, and they are ruthlessly dedicated to eliminating the competition. We'll talk about CCleaner from 2017. This one has been linked to APT17, we mentioned them earlier, and more specifically, a subgroup known as Axiom, again, historically engaged in supply chain attacks. The CCleaner attack showcases technical knowledge, preparation, and patience. The timing was strategically advantageous because the original owner, Piriform, was in the process of selling to Avast. Anybody who's ever sold a car, or more important, let's say you're selling your house, you know what goes on. There's a lot of distraction and confusion. So it would be easy to miss things in the network that didn't belong there. The attackers took their time to move laterally in the network during off hours to avoid detection. And within a month, they had installed a modified version of ShadowPad backdoor malware to escalate their privileges. And then they distributed a cryptographically signed version of the modified CCleaner product. No one suspected anything. So let's take a little walk through that attack step by step. For initial compromise, they accessed unattended workstations of a CCleaner developer, just this one actually, which was connected to the Piriform network via TeamViewer for the win remote. They reused credentials, we've talked about this many times, haven't we, from previous database breaches, and they used those to access that TeamViewer account. They delivered malware then using VBScript, and they went on to develop their malicious version of the CCleaner product. Using RDP, they opened a backdoor on a second unattended but connected computer. There they dropped a binary and a malicious payload of second stage malware, and this was delivered to 40 CCleaner users. And then they compiled a customized version of the ShadowPad backdoor to allow for further malicious downloads and data theft in preparation for the third stage, where they installed their third stage payload. That malicious version had multi-stage malware to steal data and send it back to the command and control. As for action on objectives, well, all that data probably went into future espionage projects. In 2017, APT-17, also known as Barium, delivered ShadowPad malware to infect enterprise networks via a product known as NetSerang. Now, NetSerang specializes in server management and security connectivity software that was used globally by major organizations. We've heard about that stuff before. It seems to be a popular choice. A module hidden in a code library was making suspicious DNS requests and sending data back to the operators, who then decided if they wanted to go ahead with it. If they did, they would send a malware payload with a full backdoor to take over the system. We talked about Shadow Hammer earlier. That was the ASUS Live Update attack. 2020, Able Desktop. So this involved the Chinese APT group Lucky Mouse, who went after chat software used by the Mongolian government, agencies, as well as some private businesses. They hijacked updates in the software supply chain. Now, the attackers didn't need to steal or forge an updated signature because Able's updates were not signed. In 2020, there was Operation SignSight. This targeted the Vietnamese government's certificate authority. So this was a targeted software supply chain intrusion that could affect a wide range of both public and private entities who used the digital signature software, which provided certificates of validation and software suites to handle digital document signatures. That software is widely used throughout Vietnam. It's even mandated in some cases. Key point here is abusing and targeting something against a service oligopoly. It's not clear who exactly among the Chinese state-sponsored groups was behind this, but they're possibly the group known as TA428, who happen to have a track record of targeting East Asian countries like Mongolia and Vietnam for these supply chain attacks. Now, this is a very interesting attack with similarities to NotPetya. It just lacks the destructive malware component, thankfully. Golden Spy malware was embedded in required tax payment software that's issued to corporations who would like to do business in China. And the Chinese banks require businesses to install something known as intelligent tax in order to pay the local taxes. This is produced by the Golden Tax Department of the Isino Corporation. Yeah, it sounds familiar, doesn't it? The malware installed a backdoor on systems, which enabled a remote threat actor then to execute Windows commands or upload and execute any binary. That could include ransomware or Trojans. And the malware provided system-level privileges with the capability of executing any software on any system where it's installed. And interestingly enough, just because you removed the tax software, you did not remove the Golden Spy malware backdoor. It connected to a CNC that was distinct from the tax software. So what have we learned? Well, there is a new executive order, which is a great starting point. But as you've probably seen, this picture's far bigger than we realize. There's a whole lot of dependencies. What can we do? Well, package management is an ongoing challenge that we can do better. A registry of record will help us to improve reliability in that chain. Code signing is important. Following the practices of making text secure by default, using something that we're talking a lot more about known as a software bill of materials. Eric Sheehan of Symantec, who happened to be integral in helping investigate and decode Stuxnet, likens this to finding a needle in a haystack, having the right security, telemetry, and visibility at the right control points in your organization. So here are some takeaways. We need to be paying more attention to the open source code that we use. It's time to change what we've been doing to identify and remediate risks, because we're missing things. Those legacy security tools in use, they're not securing us. Here's something new I'll share with you, and this, because it's time to level up. SigStore is from the Linux Foundation, and it seeks to empower software developers to securely sign software artifacts. Things like release files, container images, binaries, bill of material manifests, etc. The signing materials get stored in a tamper-resistant public log of all activity for accountability of every submission. And it's free for use by all developers and software providers. And you can see the link there. Package Hunter is a new tool from GitLab that you can use to detect malicious code and also behavior that you're not expecting in your dependencies. Because, as we know, there could be a lot of malicious packages in the wild. This is free and it's open source. So I will end with this. I love podcasts, and one of my go-tos is Risky Business. They had an excellent segment about Operation Aurora with Mark Rogers from Okta, whom I've referenced a few times in here, and I will again now. If you can gain a position of trust, you can exploit it. Think service or non-person IDs, accounts that nobody really scrutinizes, with enough privilege to leverage, to do e-discovery, and to find all the stuff you need for an attack. Because your chain is only as good as its weakest link. And there are more ways to abuse the chain of trust than people realize. Let me leave that with you. Thank you so very much for attending my talk, for the opportunity to share this with you. Those are my details there. And thank you to AppSec Village.